1988. The 1918 Spanish flu pandemic was caused by the influenza virus and is thought to have killed approximately 15 million people. Okay, you'll have heard a lot about it because it's the one that we're most commonly comparing to with COVID. Okay, humans have many defences that prevent viruses from entering the body, including physical barriers and the chemical secretions. Sorry, not the chemical, just chemical secretions. Name one of the non-specific immune responses that may result if the virus is able to pass these defences. So we're saying, assuming that it's got past, like our stomach with the acid and things in our tear ducts and stuff like that. Okay, if they've got past that, what is your next line of defence? But non-specific. So we're not looking for any of your antibody, antigen-driven ones. So I think the best one to go for is phagocytosis. Okay, because that's just roaming around trying to find things that are just not you and eating them. Okay, you also could say it's the inflammatory response, so inflammation, because that's a general call to arms, as it were, of all of the kind of normal non-specific immune responses. And in the Mark scheme as well, they also had apoptosis. So that's just any cell recognising that something is wrong, that there's been damage or something is not right, creating a signal set to just go through cell death. Okay, annual flu vaccines are designed to give immunity to some strains of influenza for vulnerable individuals. The vaccines typically contain inactivated virus particles that have been purified to leave only 2 of the proteins that are found on the surface of the virus coat. Suggest why a new flu vaccine needs to be developed annually. Okay, so it's worth 2 marks. So your first one that I'm hoping comes straight to head is that we must have a high mutation rate. So if there is a high mutation rate, okay, so high mutation means that you get lots of different, now remember it says here, purified to leave only 2 of the proteins that are found in the surface of the virus. So it's about the surface proteins, okay. So high mutation rate means that you get changes in surface proteins. Okay, and then so on the back of that, that means that you're looking for new kind of teaching with your vaccine. So if there's changes in surface proteins, your current immunity that you've been given will be no good to you at all. Okay, so memory cells from vaccination don't respond. Okay. Scientists have predicted that another flu pandemic is highly likely in the future. All these things that they were telling us, nobody ever thought there'd be a pandemic, and you're like, 2019, they'd actually even put that down that they were worried about one. Okay, they are particularly concerned that this may arise from the H5N1 strain of influenza virus, which is common in wild bird species and is able to pass from birds to humans. Don't know if I don't know when you're looking at this one, but if it is currently 2022 and just before the exam, you'll have seen lots of stuff in the news recently about worries about the number of bird flu cases that have been found in Scotland recently. So they're basically saying try and keep away from that, and you just phone DEFRA, make sure it's all sorted out. Okay, what term is used to describe the level of harm caused to the host species by a virus? That's virulence. Okay. The case fatality rate is the proportion of infected individuals who die as a result of a disease. Spanish flu had an estimated CFR of 2.5%. But the H5N1 flu strain has a CFR of 55%. If Spanish flu had been caused by the H5N1 strain and it had infected a similar number of people, what would have been the resulting number of deaths? Okay, so it's a kind of odd question. It's not that difficult though, but you have to go back up here. Okay, so we need to get the actual death toll, which was 50 million people. So what we're saying is that 50 million people, there we go, sorry, yes, no, that's right. So my 50 million people is 2.5% mortality. So I need, if it was 55% mortality. So I just put my 50 million, divide that by 2.5, and then times that by 55. because that means me taking it down to 1% and then back up to 55%. And that gives me 11,000,000,000,000. Or if I want to bounce my decimal place in, 1, 2, 3, 4, 6, 7, 8, 9, which gives me 1.1 times 10 to the 9. Scary number. Okay. Right, that's the question.